Good day everyone, and welcome to iLAN Technologies presentation on VLAN and its applications. This is part 1 in our series of webinars where we'll look at how VLANs or virtual local area networks can be used in small and medium-sized networks. In this webinar, we'll look at how VLANs can be configured and used using DRATEC routers. And in the following webinars, we will expand our discussion to include DRATEC bigger switches. My name is Java, and I'm a technical sales specialist at DRATEC Australia, New Zealand. If you have any questions during the video, please comment in the chat box on the right side of the screen and stick around at the end for a 5-minute Q&A session. If you're watching this after the live premiere, please comment below or send us an email to sales@dratec.com.au. It's time to begin. Today's session, we'll start out with a look at what a VLAN is and what sort of advantages they offer. Then we'll compare and outline port-based and tag-based VLANs. We'll also show you a video that demonstrates VLAN configuration on a DRATEC access point and a router. Other topics include bigger switch VLAN configuration and VLAN applications. As mentioned, DRATEC Layer 2 Plus bigger switches will be covered in greater detail in our next webinar that's coming soon. Let's start off by looking at what a VLAN is and why we need to use it. If you were to look up the definition of a VLAN, it would read: a virtual local area network, VLAN, is a logical group of workstations, servers, and network devices that appear to be on the same LAN despite their geographical dispersion. The VLAN information is in the Layer 2 header of an Ethernet data packet as shown in this diagram. It is 12 bits of data between the type and source MAC address sections of the Ethernet packet. So in other words, a VLAN is a group of devices physically on the same LAN as other devices, but separated from them using information in the Ethernet packet, and they don't necessarily have to be all together in one place. Using VLANs allows you to segregate your network and prevent devices in one part of the network from getting access to other parts in the network and vice versa. VLANs allow you to segment your network by function or application. Unicast, broadcast, and multicast packets are forwarded and flooded out ports in the same VLAN. This also enhances the network performance since broadcasts and multicasts are not sent to other parts of your network. VLANs also ease network configuration by logically connecting devices without physically relocating those devices. Here we have a typical application of VLANs. We can see 4 local area networks: administration, sales, support department, and the warehouse. The devices in each of these LANs could be in different locations within the company, but are logically part of the same network. Some of you may be looking after large networks, which may have IP cameras, IP phones, and so on, in addition to your PC data network. You'll find that if all of these devices are installed in a flat network, you will soon see network congestion resulting in slow network response times as well as poor phone call quality. The solution is to separate each of these services by using VLANs. One of the benefits of using VLANs is that it increases the number of broadcast domains, hence reducing congestion and improving performance of the network as described in our previous slide. VLANs can also be used to create logical groups and allow communication between required subnets. Firewall rules can also be used to control data flow between networks where routing has been enabled, thereby helping to secure the network External threats are, of course, minimized. If an outside attacker is able to gain access to one VLAN, they'll be contained to that network by the boundaries and controls in place to segment it from others. Also, VLANs are not restricted to just one switch. They can span across multiple switches, hence increasing flexibility to your network. And grouping is logical here, not physical. To illustrate this, let's say within a building we have the sales department on first floor, but one of the salespersons is located on the second floor. So no matter where the PC is placed in the network, it can still be a part of the sales VLAN. VLANs also help to make network administration much easier. By logically grouping users into the same virtual network, you make it easy to set up and control your policies at a group level. When users physically move workstations, you can keep them on the same network with different equipment, or if someone changes teams but not their workstations, they can easily be given access to whatever new VLANs they need. Troubleshooting problems on the network can be simpler and faster when different user groups are segmented and isolated from one another. If you know that complaints are only coming from a certain subset of users, you'll be able to quickly narrow down where to look to find the issue. VLANs also provide improved quality of service by managing traffic more efficiently so that end user experience better performance. There are also fewer latency problems on the network and improved reliability for critical applications. VLANs can also be used to prioritize traffic to ensure critical application data keeps flowing even when lower priority traffic such as web browsing spikes. We'll now look at the different types of VLANs. The two main types are port-based and tag-based VLANs. Starting with port-based VLANs. As shown here, the VLANs are assigned to the LAN ports on the router. So any devices plugged into one of these ports will be a part of that VLAN. We have three VLANs shown here. VLAN 0 for sales and VLAN 1 for admin, and a guest Wi-Fi VLAN. Each of these workgroups will be isolated from each other, but can still access the same internet connection. The next type of VLAN is 802.1q tag-based VLANs. In the example shown here, we have three different workgroups connected to a switch shown by the different colors. The VLAN ID is limited by 12 bits or 2 to the power of 12, which gives a maximum limit of 4096. The actual number of VLANs that can be configured will be limited by the router or the switch model and would usually be a number between 2 and 50. To achieve this, we have a single port on the router configured with multiple VLANs which also have a VLAN tag. This is the VLAN trunk connection, which is connected to a managed switch. In the example shown, we also have the three different VLANs in the VLAN trunk connection to the switch. Each VLAN, shown by the orange, green, and blue colors, can be for different workgroups. The VLAN tag is inserted into the data packet header, and this is usually used to identify which VLAN it belongs to. Another parameter in the VLAN tag is the 802.1p setting. This is used to specify the priority level of the data packets, and it ranges from 0 for best effort to 7 being the highest level. If you want to allow communication between each VLAN, then inter-LAN routing has to be enabled between them. In this diagram, we only want to allow communication between the administration workgroup and the sales department. So we enable routing between these two LANs. I'll briefly show you the configuration steps to set up VLANs in Draytech routers. We'll start with port-based VLANs. This applies to DreOS routers such as the VIGA 2862 and VIGA 2927, as well as others. The steps involved are also covered in knowledge base articles that are available on our website. Step 1 would be to go to LAN, VLAN config menu, then select Enable. The next step is to assign all ports and SSIDs to a VLAN. Select LAN subnet for the VLAN in the circle there. Ensure all LAN ports and SSIDs are assigned to a VLAN. The number of ports and LANs will vary by the router model. Also do note that we do not enable VLAN tags for port-based VLANs. The next step is to enter the LAN subnet details for each LAN, including the DHCP details. Enable routing if required by selecting the intersection of the two LANs you wish to route between. Here you can see we've enabled routing between LAN 2 and LAN 3. For Linux-based routers such as the VIGA 3900 and VIGA 2960, the setup is different. First step is to create the VLANs and then assign the LAN port as untagged. The next step is to configure the LAN subnets for each VLAN. In the example here, we have assigned the subnet 192.168.50.1 to VLAN 100. For inter-LAN routing in Linux routers, we only have the global option to enable inter-LAN routing. We need to select Enable Inter-LAN Route. With the Route Group feature, as shown here, you can use groups to allow or block routing between VLANs. You can also use firewall rules to control traffic flow between the VLANs. Setting up 802.1q tag-based VLANs in DreOS routers is similar to the port-based VLAN setup, but includes a couple of extra steps. Step 1, like I mentioned, is to go to LAN VLAN config menu, then select Enable. The next step is to assign all ports and SSIDs to a VLAN and select a LAN subnet for each VLAN. The extra step is enabling the VLAN tag and assigning a VLAN ID. The priority setting is optional. A value of 0 is the lowest priority and 7 is the highest. It is recommended to also select Permit Untagged Device in P1 to access the router, as I have highlighted here. The reason for doing this is that usually we will have a switch between the router and a computer, and the switch handles the tagged data packet. But if for some reason you want to connect a computer directly to the router, it will not be accessible. The next step is to enter the LAN subnet details for each LAN, including the DHCP details. Enable routing if required by selecting the intersection of the two LANs you wish to route between. Here we've enabled routing between LAN 2 and LAN 3. For Linux-based routers, select the VLAN for the member to be a tagged VLAN. In the example shown here, we've selected LAN port 2 to be a member of VLAN 30, which will make it a tagged VLAN. We now need to set up the 802.1q trunk port. This is needed when connecting the router to a smart switch, and we require all the VLANs to be available on the switch ports. In DreOS routers, select all VLANs to belong to the same LAN port. In the example here, we've assigned all the VLANs to port P1. For Linux routers, to set up an 802.1q trunk port, we just select all the tagged VLANs to belong to the same LAN port. In the example shown here, we've got LAN port 2 that's configured as the 802.1q trunk port. A typical application of VLANs utilizing the 802.1q trunk is shown in this diagram. The switch is connected to the router, and we connect the PCs to the switch LAN ports, with each department assigned to a VLAN. Now here's a short video that was created a few years ago which shows how to configure VLANs on an access point and connect to a Dwaytech router via an 802.1q VLAN trunk. The video is available on YouTube at the link shown. I'll also include a link in the description below if you'd like to check it out later.
Hey everyone, this video demonstrates how to set up your access point with multi-SSID. We can set up multi-SSID to separate wireless clients to different subnets. Here in this example, EP connecting to a router has multiple subnets and it is passing traffic via trunk port. We will configure EP900 and VIGA 2860 one by one. So let's configure VIGA 2860 first. Connect VIGA 2860 to a computer, open your web browser and log into VIGA 2860. Here we will configure 4 LAN subnets with network address 192.168.1.0, 2.0, 3.0 and 4.0. All with subnet mask 255.255.255.0. To configure LAN 1, go to LAN General Setup, click on Details page, enter IP address, subnet mask and DHCP configuration. Similarly, we need to configure LAN 2, LAN 3 and LAN 4. At this stage, router does not allow to configure remaining LAN subnets as they are inactive. To make them active, we will go to LAN VLAN configuration. Enable VLAN. We will use port 6 as a trunk port, hence it will be part of all the VLANs. Now select LAN subnet, enter VLAN ID under VLAN tag. Now let's allocate remaining ports. Here we will keep remaining ports under VLAN 4 as untagged. Click OK to save the settings. After router restarts, log in to the router again and go to LAN General Setup and configure remaining LAN subnets. For that, first enable LAN 2, LAN 3 and LAN 4. Now check IP, subnet mask and DHCP settings for LAN 2 and change if required. Similarly, check LAN 3 and LAN 4. Now we'll configure access point. Connect EP900 to a computer. You'll need to use static IP to a computer to access EP900 as DHCP server is inactive by default. Now go to LAN General Setup and disable DHCP client. Ensure that DHCP server is turned off so that all IP addresses will be assigned by VIGA 2860 only. Then go to Wireless LAN General Setup, enable Wireless LAN, uncheck Enable 2 subnet option and configure 4 VLANs with different VLAN ID as set on the router. Enter SSID name for them. Now go to Wireless LAN Security. For each SSID, select an authentication mode, WPA algorithm and enter passphrase. Click OK to save. Also set key renewal interval to 3600 if not set. Both devices WIGA 2860 and EP900 are now configured. We will connect LAN port number 6 of 2860 to EP900 through a network cable. Now we will test the setup. From laptop, go to wireless and try to connect SSID one by one and check IP addresses. Wireless client getting IP address according to the SSID it connects to. Hence, only one LAN physical connection between router and EP can pass the traffic for all VLANs. You can also enable inter-LAN routing under LAN general setup to allow communication among 4 VLANs.
Now we'll briefly take a look at VLAN options in DRAETEC WIGA switches. We'll go over VLANs in WIGA switches in more detail in our next webinar. In a large network, as shown in this diagram, much of the data traffic is between devices or servers on the local network, so not much traffic needs to go to the internet. For instance, IP cameras store videos to the local NVR, the IP phones register to a PBX, and documents and files on your PCs are stored on a local file server. Utilizing VLANs as well as Layer 2 Plus features in DRAETEC WIGA switches will improve network performance and also reduce the need to have a higher end router to handle local traffic. The configuration steps we use when setting up VLANs in WIGA switches are: add the VLANs by selecting tagged or port based, assign VLAN memberships for ports, assign a port as trunk port, and finally configuring the ports. In WIGA switches, we have 3 different types of VLANs. These are voice and surveillance VLAN, MAC based and protocol based VLAN. Again, these will be covered in more detail in our next webinar. Central switch management in DRAETEC routers provides a convenient and easy way to manage and configure VLANs in WIGA switches. Instead of logging into each switch and working through the configuration pages, you can just log into the router and centrally configure and deploy the switches in your network. You can also monitor the switch and LAN client status as well as perform maintenance tasks. It also allows easy deployment. Here we have a screenshot of one of the configuration pages. The VLAN configuration is quick and easy by using the graphical user interface. With a few mouse clicks, VLANs can be assigned to switch ports, and it'll also update the router VLAN configuration. It will auto-detect uplink and downlink, and also auto-configure PVID for the access port. Furthermore, it will auto-configure a trunk port when multiple VLANs are selected. The PVID value can be selected from a drop-down menu. We will deep dive into central switch management in a future webinar, where we'll talk about DRAETEC switching technologies. Let's look at some typical scenarios where VLANs can be advantageous. Let's assume that a company wants to separate the employee Wi-Fi network and guest Wi-Fi so it can restrict network access for guest users. We want guest users to be able to access the internet, but we don't want them accessing other LAN resources such as the servers, printers, and internal portals. So 2 VLANs can be defined here to accomplish this. That's VLAN 1 and VLAN 2. The LAN subnet for VLAN 1 can be set as 192.168.1.0, and the subnet for VLAN 2 can be set as 10.0.0.0. And of course, in this case, we want to keep inter-LAN routing disabled. Another scenario is where 4 companies are located in the same building. They share the broadband network and use a WIGA router for load balancing, security, and VoIP features. So 4 VLANs can be defined, VLAN 5, 6, 7, and VLAN 8. There can be many other instances where VLAN can be very, very helpful. Another example where VLANs are used is in adding a VLAN tag for the WAN connection. This is set up in the WAN General Setup configuration menu in DreOS routers. Some NBN service providers use VLAN tagging for WAN connections. When connecting a DRATEC router to the NBN via one of these service providers, you'll need to enable the VLAN tag. Otherwise, data connection will not be available. Most ISPs in Australia use a VLAN tag of 100 or 2, but there are a few exceptions. The table you see at the bottom shows service providers in New Zealand who use a VLAN tag of 10. The example shown here is for New Zealand, where we need to place a Vodafone router with a built-in ATA for VoIP services behind the DRATEC router. Here the WAN connection uses tagged VLAN, and the attached VoIP router also requires a tagged VLAN connection coming from the DRATEC router's LAN port. Now this screenshot shows the settings we've used. We've basically configured VLAN 1 on LAN port 4 as a tagged VLAN port with a VLAN ID of 10. All other ports and SSIDs are allocated to VLAN 0 with no VLAN tags. All right, so that brings us to the conclusion of today's session. Let's summarize the key takeaway messages, which are VLANs help in improving network performance by reducing the congestion, enhancing the security, adding flexibility, allowing a logical grouping of users by function, not location, and they make it easier to administer networks. DRATEC routers and switches support port-based and tag-based VLAN. DRATEC routers support VLAN tagging on WAN interfaces as well, which is something that's often required by the NBN ISPs in both Australia and New Zealand. Something that we didn't really have time to get into today, which DRATEC routers also support, is virtual WANs. This allows simulating several WAN connections through one physical WAN connection, which is often used for triple play services in some countries. Well, that's about it from me, but please do stay tuned. We'll be answering questions in the live chat on the right of your screen for the next 5 minutes. For more information about DRATEC products, please check out our website at www.dratec.com.au or send us an email to sales@dratec.com.au or just give us a call on 0298 388 99. Please like and subscribe below. And if you'd like a notification of new Premiere videos we're about to launch, or anytime we put up a new video, just give the bell a click too. Thank you for your attention. I hope to see you again soon. Goodbye.